Okay, so today we'll talk about Numpy. Okay, Numpy stands for numeric Python. Okay, so uh, it is the core, what do you call, scientific um, library. Okay, so the core scientific kind of work we can achieve using Numpy. Okay, you can have okay, so we'll see an example one. Okay, one example, we'll see how to declare a Numpy, and then we will see the usage of Numpy. Okay, so let's say I give vals equal to range of 16. So what will range of 16 do? So when you say range, what does it do? Hmm? Divakar, Vamsi.
0 to 15.
Right? It's going to generate values from 0 to 15, right? 0, 1, 2, so on to 15. That means we'll have 16 values, right? Now, what I'm doing here, I'm saying mat1, I'm converting this into metrics. I'm converting this into a matrix format. So NumPy will convert into matrix format. Okay. So to use NumPy library, we have to import NumPy. So I can say import NumPy. Now, if I import NumPy, I have to say NumPy dot, okay, reshape. So you have reshape. Now, reshape method of NumPy will reshape the value. So range will generate a range of number, right? It's a one-dimensional linear values. I'm saying I don't want linear values. Reshape what? Reshape values into 4 by 4. Now I cannot say 4 by 3 because 4 by 3 needs 12 values. So it will not fit, right? So you can reshape range 16 into 4 by 4 or 8 by 2, 2 by 8, 16 by 1, right? But definitely not 4 by 3 or 5 by 4 or something like that. So I'm I'm taking values and I'm reshaping it into 4 by 4 format. Now when you print mat1, okay, so let me run this p1. You see, this is your matrix, right? I'm saying 4. 4 is first value is rows and second is column. Now if I say 15, okay, and I make this as 5 here, and I'll make this as 3. So how many rows we have here? 5 rows and 3 columns. Okay, so when you run it, okay, so 5 rows, this is your 1 row, second, third, fourth, and fifth. So these are your 5 rows. And how many columns? 1, 2, and 3. So you have 3 columns. You have 5 rows and 3 columns, right? So this is how you can create a 2 by 2 matrix, which is your NumPy. Okay, it's a matrix. And we'll do some basic operation and then we'll talk about different matrix operation. Okay, so the first thing we'll do is we'll try to read the value subset indexing. Okay, now the indexing is going to be a little different than how we index, let's say, string or a list, because list, string, tuple, those are all linear, one-dimensional data set. Now we have two-dimensional data set. Okay, so if I say here, okay, I'm going to say print and I'm saying 1 colon and I'm saying mat 1 bracket. Okay, indexing is always which bracket? Square bracket. Indexing, no matter whether you're using string or list or tuple or numpy, it is always square bracket. Now when I say mat 1 3, Okay, I'm talking about third row, right? Or rather than fourth row, because indexing starts from 0, isn't it? So this is your 0th row, first row, second row, and third row. So I'm going to get this row. All right. Now let's say um, I want to get third row, okay, and say second column, row, comma, column. So this is your row. Now you say comma and column. Second row means I have to give 1, right? 0 is this one, 0369. 1 is 14710. And this is your 258 is your third column. So now when you run it, you see, I'm saying fourth row, this is your fourth row, and second column is 10. That's why you got 10 here. Okay, so if if you want only one row, then you will just give the row number. If you want row and column specific value, you will give row comma column. Now I want second row, but all the values in that column, right? So in that column, what are the values? You have 1, 4, 7, 10, 13. These are the values in the column. I want all the values in second column. Then what will I do? I'm going to say colon. What does colon means? From beginning till the end. Before colon, we give starting value. After column, we give the ending value. So we are saying begin from starting value and go up to the ending value. Right? So starts from 0, goes all the way up to last. So first column, you have 1, 4, 7, 10, 13. So now when you run it, so see, you got 1, 4, 7, 10, 13. Yes?
Hey, Swap, it's Shivaya.
Sorry?
Hi, it's Shivaya. Swap, I
Yeah.
have a clarification.
Yes, you are.
Swap, this is good. So I want to know that is it possible to pull, for example, right, in the row one, the first two columns, but not the last column? Is it possible by
Yes.
this?
Yes. Yeah, because we have done this before. So,
Oh,
and,
sorry.
and no problem, no problem. Okay. So that's why, we have done one dimension. First time we are doing 2-dimensional. Okay. So now what happens when you see this colon here? Before colon, we give the starting value, and after colon, we give the ending value. Okay. So when
Oh,
you
got it.
don't give any value,
Yeah,
it means
it
that
pulls all. Okay,
all exactly.
we got it.
So, okay, and in Python, two things have to remember here. In Python, starting value is 0 always. Okay, Python counting
Yeah.
starts from 0 by default. And so if you want 13, for example, so the position
Mhm.
of 13 is 0, 1, 2, 3, 4,
Yeah.
right? But ending should be 1 more than 4.
Mm-hmm.
So
Yeah.
what happens? It's like you're saying from 0 to 5, give me values between 0 to 5. Okay.
Yeah.
So 0 is included and 5 is up to 5. Up
Up
to
to
5.
okay.
Ending
Okay.
is always up to. Okay.
Mm-hmm.
And starting is including. So if you want starting, so you'll say 0. And if you want ending, so ending index plus 1, 5. Okay. So if I do, I'll get same value, right? Now let's say we'll look at what you asked. Now let's say here, let's say you want 4, 7, and 10. Let's say,
Mm-hmm. Yeah.
right?
Yeah.
So now we are starting from which position? 1,
But okay.
right? So I'll make this as 1, and you want 1, 2, and 3.
Three.
Want
Okay.
1, 2, and 3. So you have to make this as 4.
Oh, okay.
Okay. So when you make 1 to 4, you get 4, 7, 10.
That's awesome.
Okay. Now let's say I gave column 1. So it's giving us 1 column. Now let's say
Yeah.
I want these 2 columns.
Hmm.
So starting is 1 and ending is 0,
Colon.
1, 2. So I'll make this as 3.
Okay. 3. Oh, okay. 3.
So now you get 1 and 2 both. So 1 and 2 you have, let me give slash n here so that it comes in next line. Slash n, we'll put it in the next line.
Yeah.
So see, you get 4, 7, 4, 5, 7, 8, and 10, 11. Now, since you want up to the last value, you
Yeah.
don't have to give any value here.
Then remote. Yeah. Okay.
Yeah, so it will give us same result. Okay, so the ending value we don't have to give. So right side, it is the for ending value, left side it is for starting value. So if I don't give anything on the starting, that means it is starting from 0. And when I don't give anything in the end, it means ending value is n
Till
to
the
10
end. Okay.
values. So this is how you can get subset, yes.
And Swapnil, I also wanted to understand, right? Where do you actually apply this concept?
Matrix. Okay, so this gives you matrix. So if you uh, wherever you use matrix concept. Okay, now tomorrow around same time, tomorrow I'll take one application. Okay,
Yeah.
where we will see the importance of matrix. Now let's say in linear programming, okay, linear programming we use linear algebra. uh, so we'll look at a problem and we'll form equation first, and then we'll solve this. So let's say equation is 2x plus 5y equal to 15, and okay, 3x plus 4y equal to 20, right? Now this is a form of linear algebra form. So this can be solved using matrix format.
Oh,
Okay.
the because it's a two variables.
Correct. Two
Oh,
variables, is it? Yeah. So this will be your one matrix, 2, 5, and 3, 4. This is your output matrix, and this is
yeah.
XY is a variable matrix. So we do that.
Awesome.
Now, and when we do machine learning, okay,
Yeah.
many a times we'll have to pass value in this format. Okay. So that's where NumPy is used. But main purpose of
Awesome.
NumPy is to read it in a multi-dimensional, two-dimensional format. Okay, and then um, most of the like if you talk about machine learning itself, right? The base or foundation of machine learning is your matrices, vectors. So that's why NumPy is important from machine learning perspective,
But
right?
this is awesome. Yeah, I like that.
Yeah, and we will. So first, we'll just learn how to use this today, and tomorrow we'll solve. We'll take a linear algebra problem. We'll see what is linear algebra in business. Right now, see, this probably would have done in 9th class or 10th class, right? But what is significance of this? Significance of this comes in where um, you have, let's say, you want to start a business, right? Now, in that business, there will be multiple variables. Correct. Let's say you want to start car manufacturing. Now, car manufacturing will have seat, number of nut bolts, so many variables you have. Now, let's say one car needs 2 types of something, 5 types of something, 7 types of something else. You'll have multiple variables, right? We just a 2 variable example, X and Y. Car might have 200 variables, right? and and that will give you, let's say, 15 cars, for example. Then you have another model. This is model 1. Then you have another model which uses 3 parts of first variable or first material, 4 parts of second material, and this is going to give us 20 cars. So how many XY inventory should I order? Right? So again,
Yeah.
so we can use matrices or NumPy to solve this XY, and then we know, okay, so many quantities of X, so many quantities of Y we need to order. So we'll take one example also tomorrow, and we'll see where the application of this one. Now, NumPy, NumPy is used when you have this equal to sign. Okay. But in linear algebra, you also have linear algebra, linear programming. You also have concept where there's inequality. Okay. For that, we use what is called a SciPy, scientific Python. Now, scientific Python is a library which is again built on NumPy. So to use SciPy, you need to use NumPy. Okay. So that's where again NumPy is used. Okay. And of course, machine learning is fund, it is based on vectors or matrices. So we use there as well. Okay. Now, most of the
Awesome, sir.
time, sure. Most of the time, you will not see NumPy being written like because it's a 5 character. People rename it. We call as giving it as an alias. So I'm saying I don't want to use NumPy everywhere. I'll give an alias called NP. So now you don't have to use NumPy. See, it's already giving red line error. You can directly use np.reshape. Okay, this is alias that we are giving for NumPy. So once you give the alias, then everywhere in the program, wherever you are using, you need to represent NumPy as NP. Okay. So let's say you get a matrix and you want to see the shape or what is the rows and column. So you can say shape of, let's say, mat1 itself. Okay. It should give us 5, 3, correct? So to to get shape, so you say mat1 dot shape. Shape is a variable, not a function. So it's going to return us shape. You see, it says shape is 5, 3. Now this is the tuple. We can access. Now how many rows are there? So I can say print number of rows equal to, okay, mat1 dot shape. So this is going to give us 5, 3. If I say 0, this is your first element and this is your second element. So if I say 0, so this will give us 5. So number of rows equal to 5. Similarly, I can say number of columns equal to shape 1. So you get number of columns equal to 3. Right? A. Now, we'll see some standard function to generate, these matrices. Now, let's say you want to generate all zeros matrix. So you can say mat2 equal to np dot, okay, you have zeros. And here you give the size 4, 4. So it's going to generate a matrix of 4, 4. I'm going to say matrix 2, okay, equal to slash n comma mat2. So see, it's a 4 by 4 matrix and all the values in matrix is 0. Similarly, if you want to generate ones, you can say here ones. Right? You got matrix. If I want twos, what should I do?
I think it should be twos there.
Twos?
Or do you have any dot twos?
Yeah, so we have full.
Full. Okay.
Okay, so full is like saying I want specific for zeros and one, you have special functions, but for full, okay, for anything other than 0 and 1, you can say 4, 4 full, and full will take 2 parameters. Full will take 2 parameters. The first one is size, and sorry, second one is the value. So you say 4, 4, 5.
Which will have all fives. Oh, okay. Hey, Swapnil, I have one question, right?
Yes.
Why the previous one did have some dot, but
Yes.
not here?
Good question. So this dot is to indicate that this is a float value, decimal value.
Oh,
So
okay. Okay.
it is to indicate 1.0.
Oh, got it.
Okay. So this is to indicate that it is um, 1 comma 0. So by default, okay, numpy ones or twos will give you float values. Now, if I say 4 comma 4.0 here, you see, you got 5 dot also.
All right. And actually, in the Python, it does not consider like a zero as like it does leave blank. Why it does not display as 5.0? Rather, it just displays a 5 point.
Yes, it display 5 point to indicate that there's nothing, there's zero place. I mean, there's nothing after there's so point indicates it's a float, but
Mm-hmm.
zero means there's nothing. There's no value. But if I
Okay.
make it as
Okay.
5.1, let's say, or 5.001,
It should display there. Okay.
then
That
in this case,
that's
because there's a decimal value.
got it.
You know,
And that's the, I think, convention used by Python, I
Python,
guess.
exactly.
Yeah, yeah.
Exactly.
And you should be able to generate random as well, I guess.
Oh, yes, you can generate random. So you have NumPy random. So let's say I say mat3 equal to np dot random. Okay. Now random is a um, NumPy is a library. In that you have a random sub library or module we say, and here you can have multiple functions. So random, okay, random will generate random value between 0 and 1.
Mm-hmm.
Okay, so if I give size 3 comma 3, right, and I say matrix 3 equal to matrix 3. So all these values will be random number between 0 and 1. So 0.8, 0.6,
Oh,
point
okay.
0.2,
Okay.
0.1.
Okay.
If you want integer value, so we
Yeah.
have something called as rand int.
Oh, okay.
Rand int. Rand int. Now, rand int, you can see the size. It takes low value, high value, size. Now, D type here indicates data type. Okay.
Mm-hmm.
So here if I say data type, okay,
Data. Okay.
D type, and here if I say integer, it will generate integer. Okay. So you can give that. And here I'm going to say random here. It takes low and high. So I want to generate random integer value between 10 to 50.
You can give the range as well. That's good.
Yeah. So this is the low range, high range, and this is the size. So now when you run it, oops, random takes, rand into, okay, not here, sorry. I missed to scroll.
Random. Okay. Okay.
Yeah, in
Yeah.
rand int. So 10 comma 50. So I'm giving low value as 10, high value as 50. So it generates a random number between 10 and 50,
Hmm.
both including. So it is possible to have 10 and
Yeah.
50, both in this case. And yes, if you generate it, see this is 35, correct? Now when you rerun the program, it becomes
Oh,
33.
it generates something new.
Yeah, it has,
And does it actually generate the same number again anywhere? Yeah, like it may generate, right?
it may generate. Okay. So
Yeah.
we have something called as uh, called seed. Is it seed? Okay. Now there is a command. Okay. So see, when you say random number, it uses some technique to get random number, right?
Yeah.
Now, uh, now let's say if you give seed, so seed is like giving a formula. Okay.
Okay.
So if now again, if you run and if you run this program or I run this program again and again, value will change, isn't it?
Yeah.
But if you give this random number dot seed, okay, it will fix it to a specific value. So let's say, let's say I give np dot random dot seed, and I say 100. Okay, any value can give between 1 to million, any value can give. Uh, when I say 100, I'm saying, okay, that fix, okay, fix the formula, whatever formula you have, use 100 formula, whatever, right? Now, when I run this again, okay, now what I'll do, I'll just save this just to show that, we're getting same value. Now, again, you run it. See, you got exactly same value.
Oh, okay.
So it's like, use 100 formula, whatever the 100 formula is, use that.
That's good. Oh, okay. Oh, they have a formula that, oh, okay.
Some
The
way to
100th
generate
formula.
this.
So 99 may change something else, right?
Yes.
Okay.
Yes. And now thing is not only on my machine, when you use on your machine also,
Oh, it's the same
randomly
number.
100, you get same value. Yes.
Ah, awesome.
So this is useful when you are generating some random value. But let's say, you are working on somebody's program, right? And you're not sure if you have followed the exactly same path, right? It's random number, right? Now, when you run and I run, it will be different. So how do you know if you are following whatever I have done or not? So in that case, it's always good that you put random seed so that you can see the value. Now, when you get exactly same value, that means you have done the exact same work that I have done. Correct? So you can
Makes
compare the
sense. Yeah.
answer. And then when you deploy it, in deploy, we don't recommend to use seed.
Yeah.
This is only for designing, developing your program. Once you are
Yeah.
done, when you're putting in the actual usage deployment, then you want the program to use random number only. Then
Correct. Correct.
you don't give a seed.
Seed one. Okay.
Yeah.
Thanks, Swapnil.
Okay.
That's good.
Yeah. So this is how you can generate numpy values, and you can do indexing also, right? Now, what are different applications or different operations that you perform on these values? So again, if you go back to your matrix classes in intermediate 11th and 12th class, you would have seen different operations, right? What are different operations? You have numpy addition or matrix addition, right? You add two matrix. So let me.
Oh, we used to multiply as well, eh?
Sorry.
Oh, we used to multiply as well.
Yes.
Oh,
So what I'll
yeah.
do, I'll just save this. I'll bring it here. Okay. So that we don't have to run this again and again. I'm going to delete all this. And I'll share this code. Okay. So you don't have to note down the code. I'll share it later. So let's say I'm generating two metrics. Okay. Mat3 and okay. And here I'm saying 10 to, let's say, 15. And here I'm going to say mat4 10 to 397, right? Or I'll make it 20, let's say. And here I'll say, but from 15 to 25. So I'm generating two matrices. Okay. So you have, okay, I said 3 again, right? That make it 4 here. Okay. So these are our matrices. Now let's perform addition. Now to perform addition, okay, your matrices should be of same shape, right? You can add only 3 by 3 matrix to 3 by 3 matrix. 4 by 4 or 4 by 3 to 4 by 3. Okay, it has to be of same shape. So here we have anyway 3 by 3, so it should work, right? So you can say, let's say I call this as matrix addition. So there are two ways to do it. One, you say mat 3 plus mat 4. Now, mat 3 plus mat 4 or mat 4 plus mat 3 will give us same result. Right? Okay. So now I'm going to say run. Okay. And this is one way. Second way is there is a function called sorry, not mat3, it is numpy.add. Yeah. And here you pass the matrices that you want to add. So I'm saying numpy.add and I'm saying mat3 comma mat4. So both of these perform same thing. You see, you get same result. So here it is like 18 plus 17, 35. 18 plus 17, 35. 13 plus 17, 30. Right? So you're adding, see each of these metrics has a index. And index is row comma column, right? So this index is 0 comma 0. Row is 0, column is also 0. What is the index of 13? Row is 0,
0,2.
0 comma 2, yes. And for this 12?
2,1.
Correct, 2 comma 1. Second row and first, I mean say third row is 2 and second column is 1, right? 2 comma 1. So it, when you say matrix, it will add 0 comma 0 to 0 comma 0, 1 comma 1 to 1 comma 1, 2 comma 1 to 2 comma 1, 1 comma 2 to 1 comma 2. So this is how you get address, matrix addition. You can do subtraction, okay, multiplication, division. Matrix addition, matrix subtraction. So you say mat3 minus mat4. And here you say subtract. So subtract is a function that will do subtraction. You have multiplication. So you will say mat3 into mat4. Okay, np dot multiply. And you say here divide. So what it does is it will perform same like 0 comma 0 by 0 comma 0 or 0 comma 0 into 0 comma 0 or 1 comma 1 into, okay. So element by element it performs it, okay. This is division. But do you remember how we did matrix multiplication? Multiplication is not straight away multiplying one element to another element.
Row into column or something it was, right?
Right. Row into column. Okay. So just give me a second. I'm going to go to Google and I say matrix multiplication. Right? And this is how you do matrix multiplication. Left side. So see, normal multiplication, mat 3 into mat 4 is same as mat 4 into mat 3. But matrix multiplication, it's not same. So it takes the row and column. So for the for if the result output is let's say 0 comma 0, correct? This 58 is 0 comma 0. So 58, sorry, 0 comma 0 means 0th row of left side matrix into 0th column of right side matrix. Okay. So it's going to be 1 into 7 plus 2 into 9 plus 3 into 11. Okay. Now the next element here is 0 comma 1. So 0 row of left side into first column of right side. So it's going to be 1 into 8, 8 plus 2 into 10, 20 plus 3 into 12, 36. So 36 plus 20, 56 plus 8, 64. This will be your 64. With me, everyone, this is how we multiply matrix, okay? Not simply multiplying element to element. So here, there is a condition. Condition for matmul, okay? We call this as matrix multiplication or matmul. Print matmul, okay? This is actual matrix multiplication. There is no usage of line number 19. Okay, this is how matrix multiplication is used. So first condition, if you are doing mat 3, so mat 3 is, let's say, m into n, let's say. M is number of rows, n is number of columns. So matrix 3 is of size m into n. Multiplied by, say, mat 4, and let's say this is your x comma y. So x is the number of rows of mat 4 and y is number of column for mat 4. Okay, so here, okay, first thing first. This is comment, Shiva. Okay, so this is how you write comment in Python. So your Python will not read what you write in
No, not
hash.
the backslash. Yeah.
Yes, something like double backslash in C. Yes.
Yeah, got it. Yeah.
Okay, so one dot, one dot is first point I'm saying. Okay, your M, okay, and Y is the output of result. So if you say equal to, and let's say if you call this as result matrix, so result matrix size is going to be m number of rows and y number of columns. Okay, and possible only if n is equal to x. So if n is equal to x, then only matrix multiplication is possible. Otherwise, it's not possible. Okay, and output is going to be the row from the left side and column from the right side. So if I change, if I do mat 4 into mat 3, then output is going to be x into n. And your m and y should be equal. Right? So if your matrix size is 3 comma 3, into 3 comma 3, what we are doing right now, it's going to be 3 comma 3 only.
Yeah, there's a straightforward. Yeah.
Straightforward. But let's say if you have something like 2 comma 8 into 2 comma 8, then what we'll get?
It
Matrix
should match, right?
not possible.
Yeah.
Because
3,
what we said, inner
8,
one,
and 3.
yes, should be equal. So here, matmul is not possible. Okay, the inner value has to be same. Now, if I take same thing, okay, and this time I say 8 into 2. Then your result matrix is going to be sorry, 2 comma 2. Okay, now if I do reverse, let's say, if I do 8 comma 2 into 2 comma 8, that is going to give us
8, 8.
8
Yeah.
comma 8. So how to perform matmul? we use at the rate actually. Okay, at the rate. So I'll take 8 by 8, we'll see. So I'm going to take
And Swapnil, what
uh,
what did happen when you actually used the other function? Like, can you go up and show me the result of that?
so it will do simply 0 into 0, right? 0 comma 0 into 0 comma 0. Element by
Oh,
element.
okay. Element by element, the corresponding ones, it
Yes.
multiplies and the result, is it?
So it is 18 into 17 here.
Oh, got it,
It's
got it.
18 into 17, 13 into 17,
Oh,
17 to 13. So it is element by element. 0 comma 0 into 0 comma 0. 1 comma 1 into 1 comma 1. 2 comma 3 into 2 comma 3. 3 comma 3 into 3 comma 3. Okay. So it is doing element by element matrix. So now, okay, I'm going to say here 8 comma 2, right? 8 comma 2. And let's say here, so saying 2 comma 8, I give 8 comma 2. See what happens. Okay. So you will have mat 3. Okay. Mat 3 is 8 comma 2 and mat 4 is 8 comma 2, right? Now when you run it, see you get exit code 1. Exit code means error. Sorry. So this is not possible. Now if I do 2 comma 8, so the output will be a 8 by 8 matrix. You see, it is 8 by 8 matrix. This is your actual matrix multiplication. So when you are multiplying matrix, we should use this. Order is also important, right? A into B is not same as B into A in matrix multiplication, right? And here I can also say matmul. Okay, so you say np dot matmul. Okay, so you get same output. So this is how you perform matrix multiplication. And matrix multiplication, this is just matrix. You can also use sine, tan, cosine, all those things are available using NP, right? You asked me the application, right? You can use it for other. Just so what I'll do, we'll do one sine example. Now we haven't, okay, let's see this first. Let's say I create set of values. So I'm going to say x equal to np dot a range. So I'm generating range of values, okay, and values will be generated in radian. So I'm going to say 0 comma. Okay, now radian is your degrees into pi form. Okay, so you say 3 into, okay, 3 into 4 into whatever. Okay, so this a range is a function that will generate range of values. Okay, when I say 0, that means I'm saying create 0. Okay, and second value, I'm going to say np dot pi. So this will give me pi value. Okay, so this is the ending value, and you say 0.3. So this will generate values. First value is 0, second value is 0 plus 0.3. Second value will be 0.3. Then add again 0.3 to 0.3, 0.6, 0.9, so on, up to maximum is this value, radian. So if I say x here, you see these are the values. 0, 0.3, 0.6, 0.9, 1.2, 1.5, maximum it will go up to 9.3. You have 8.7, 9.0 and 9.3. These are the radians. Now, if you want to convert into sine, you will say y equal to np dot sine. Okay, so see it has sine, sine, cosine, sine h. Okay, these are the different mathematical function. Here I'm going to say x. So now you see, if I say here, sine values of x. Okay, and I'm going to say y. So these are your sine value for each. Sine 0 is 0. Sine 0.3 is 2.9. So it is generating sine value. Okay. So not only matrices, because in data science focus is matrices, but you can also do tan, cosine, okay, sine, tan, what do you call it? Cosine, then you have cos, right? All those things you can do. Now, we haven't done, uh, visualization. We'll do it later, but I want to show you that here, how to do visualization, okay? Just to see how the sine curve looks like. Okay. I'm going to move all this to here. And here, let's plot this sine graph. So to plot any graph, okay, you have to import matplotlib. That's the basic. Import matplotlib.pyplot. So this gives you like a Canva. Okay. So you can paint your stuff on top of this as PLT. Now PLT is the Canva. Okay. This is matplotlib.pyplot is the Canva. I'm renaming it as PLT, alias as PLT. So now you can do whatever you want to do on the Canva. I'm saying PLT.plot. So plot will plot values on x and y axis. So in x axis, I'll say x, y axis corresponding y value. And to plot it onto your screen, you will say plt.show. So plt, we are saying plot x comma y, and now I'm saying show it onto the screen. So when you run it, I'm going to share my plot. So see, this is how the sine curves look like, right? Sine goes from 0 to maximum 1, comes down to my minimum 1, -1, then goes up again. And that's how sine value increases, right? If you want to make it, see, there's a straight line here because we gave 0.3, right? Now, if you want it to be more sharper, then reduce this value that we have here. 0.05 means at every 0.05. So you will have 0, 0.05, 0.1, 0.15, so on. Our graph will become more sharper. Now you see the difference? It's like perfectly curved, right? It's bending. Earlier it was like straight line here, right? Now it's bending. But again, we'll spend time on plotting later. Once we are done with pandas and all, we will see how to connect to different data sources, CSV data source, database, get the data and plot different graphs.
Swapnil, looks like you can do all the mathematic formulas here
All
and
the math. That's
calculate.
why it's called NumPy, numeric Python.
Wow, awesome, huh?
All the mathematic functions. Yes. Now, if I go back to uh, Google here, if I say, okay, so see, we have something called as Python is very well documented language. Okay, so you can always go and say NumPy, NumPy official. Okay, so this is numpy.org. Okay, this is your official documentation site, numpy.org. Okay, numeric computing. Okay, you can actually see documentation here. And this will be a tedious process. Eh? You can use for MATLAB and all. Okay, so this is how you install NumPy, etc., etc. You can see. I can convert into 2D into 3D, so on. But directly what I'll do, type here, I will say different operations in NumPy. You see, reciprocal you can do arithmetic. So this is arithmetic. Arithmetic, you can do reciprocal, power, multiplication, division. You can start with basic, right? With basic stuff. So Python, NumPy. So this is what we have done.
And Swapnil, how about 3D also? It should be able to
Yes,
capable to create, right?
yes,
With the
yes.
canvas.
3D plot in canvas. Uh, so 3D is little different. Little you can do, right? Obviously
Yeah.
4D you can't do, but we can do 3D plots. Yes. So we'll do a couple of examples like wire mesh. Okay, as a 3D plot.
That's good. And I'm also thinking, right, the mensuration we used to have, right? A pi r
Yes.
square or the volume
Oh yes.
of a cylinder or a sphere,
Yes. Yes. Yes.
other stuff. Yeah.
Yes. Yes. So these are the arithmetic operations in NumPy. NumPy dot add, NumPy dot subtract. This is array. Array is our matrices, but you have reciprocal, 1 by power. So if I say array 3, okay, so 3 comma 5 comma 2. So we are creating a one-dimensional array. See, this is only one-dimensional, 3, 5, 2. One-dimensional. Mod. So there are a lot of things that you can perform on array. Yeah. So we'll end it here for today. Tomorrow we will see one example, or if you guys have time, we can do it. Let's do this example which I was talking about, correct? How to solve this. Let's solve this, okay? And then we will end. So that tomorrow we can go to SciPy. In fact, yeah, we'll do a couple of sci-fi and then we go to pandas is when more lengthier and better. So, okay, let's solve this.
And how extensively this is used in live? Like, do people use it?
Now,
Do they like it?
yeah. So now you see again, it depends, right? Now, if you are doing your physics kind of work
Oh, yeah. Could be
extensively,
widely used, right? Yeah.
right? Yes. SciPy is more extensively used. Like you are solving those theorems and things like that, or you are getting into pure mathematics where you're dealing with numbers, right? Different types of numbers, um, like sets and things like that, then it is very heavily used. But if you talk
Yeah.
about our data science plotting, we use little bit, not very heavily. Okay. But NumPy has to be there because when you talk about pandas, pandas is reading data from a table format. So here you're getting a matrix format. When we read data, okay, for performing any analysis, you need to read the data in the table format, right? Rows and column format. So your pandas is built on NumPy. So even though you may not use NumPy, but when you use pandas functions, they will use NumPy in within itself. So that becomes foundation. You may not use it, but the function that you use will be using NumPy. But for us, pandas is more important. Okay, how do you read data from various sources, and how do you get the data in Python as a table format? Okay. So let's say we'll solve this example. Okay. So here we need to form three equations. So how do we solve this first? Okay. How do we solve this? How do we, what is the purpose? Okay. So we have to divide this into three matrices. This is the input data, and our question is to find the value of x and y. So you have to convert this into three matrices. First is your coefficient matrix. Coefficient matrix is the coefficient of x and y variables. So you get, in this case, you have 2, 5. Correct? You have 3, 4. This is coefficient matrix. Second matrix is your variable matrix. Okay. So what are the variables? We have x and y. So this becomes x, and you have y. Then you have third, which is
Output.
constant. Yes, output or constant. Okay. Let's say output matrix. And it is 15, 20, correct? Now, how we say this? We say this that, your coefficient matrix, okay, coef matrix into variable matrix.
Is equal to output. Okay.
Yes, equal to output. Okay. But our aim is to find variable matrix. Okay, x, y. So we need to bring coefs this side.
Oh, are you actually dividing that?
We will just show here, but
Okay.
Python will do it. Yeah, Python will do
Yeah,
it.
yeah.
So here you say variable equal to inverse of coef matrix
Into output.
into output. Yes.
Okay.
We have something called determinant. Again, if you remember your classes from school days, you will remember. Determinant is a single value that matrix will represent. So if determinant is 0, you can't find inverse. Okay. So first have to check if determinant is 0 or not. If it is 0, then we can't solve this. If it is non-zero, then we have to perform inverse of coef and multiply matmul with output. That's it. Check
Yeah.
if determinant is non-zero and then solve it.
So what's the determinant here? I forgot.
Determinant, okay, it's a complex. For 2 by 2, it's easy. For 2 by
Okay,
2,
okay.
it is 4 into 2 minus 3 into 5. 8,
Oh,
yeah, 8 minus 15 minus 7, non-zero. Great.
okay. But it should not be a 0.
Not should be, yeah, it should not be 0. Otherwise, inverse is not possible.
Oh, okay. Infinity it becomes or something.
Correct, correct. And for
Oh,
3, we keep one constant, then multiply by 2. Okay, so it becomes complex as you go, as you increase the number of elements. Okay. Okay, so first thing first, we need to find it. First, we need to create all this, right? So I'm going to say coef matrix. So how do you create here you can say, um, okay, so anyway, here, okay, so to convert into your list into matrix, okay, so this is your list, right? So we'll make this as double list. So you have list 2 comma 5 as one list, and then second list is, sorry. So this is a simple list. Shiv, we'll do it later. I'll show you. Okay. So this
yes, please.
is a list. Now, if you have to convert this into NumPy matrix, we'll say np dot array. Array, you can even create 3-dimensional also. Okay. So I'm just converting to 2-dimensional. This is how you get coefficient matrix. If you want to just be sure that we got it right, you can print coefficient. So see, this is 2534. This is what we wanted, right? 2534. Now, second one is the output matrix, correct? NumPy dot array. Okay. And output matrix is again 2 rows, right? So this is your 1 row and this is your second row. One row has only one value, 15 and 20. So I'm going to say 15 and 20. Okay. Now to perform this, we need to perform the determinant of coef matrix, right? So determinant of, let's say, coef equal to np dot, you have linear algebra, which has det function. So if you do that, you can directly see the determinant. So we can say determinant of coefficient matrix equal to, it should give minus 7, right? We just calculate it as minus 7. It should give minus 7. So it is minus 7. Since it's a float where it says 0, 0, 0, 0, 0, infinite 0, and so it says 0, 0, 0, 1. But it is basically 7, right? Okay.
Okay.
So if,
Hey, Swapnil, sorry, Swapnil, I just had a one clarification.
yes,
In the row 27, you put np dot. What is this lingal?
yes,
What does it do?
correct. So see, what happens? We've been talking about packages, correct? Now, packages basically means you have basically files, okay, which has multiple functions, okay?
Sorry, if it is already covered, ignore it. I
No,
can
no, no
talk to you
worries. We'll
later.
be revision for them. So you have NumPy, and a NumPy has most of the functions, okay? Now, in that folder, you can have more packages. So you have a NumPy folder. Inside that, you have one more folder called linear algebra. And these functions,
Oh,
okay,
linear algebra.
that is a
Got it.
function which is in this file. And this file
Mm-hmm.
is in another file,
Oh, okay, okay. It's a hierarchical way. Yeah.
hierarchical based, yes.
Oh, got it, got it.
So far we've been using all those which were in NP only. But
Yeah,
now we are going to a folder inside NP, which is linear algebra, which has functions for linear algebra. So here
got it.
you have
Got it,
determinant,
got it.
here only you have inverse. Okay, we have to find inverse also next, right? So
Oh,
inverse is also in linear algebra only.
so basically determinant is within this particular.
Within this, yes. And this
Yeah,
is
got it.
within NumPy. Yes.
Okay, okay.
So if
Thanks. Yeah.
that, no problem. So if that, okay, is equal to 0, we say can't find the solution for this problem, right? Or whatever you want to print it. else, that means determinant is non-zero. So non-zero means you have to multiply matmul inverse of coef into into the output matrix, right? So your result matrix equal to, okay, matrix 1 at the rate matrix 2. So at the matrix 1 is what? Coef, not just coef, but inverse of coef, right? So I'm going to say np dot lean algebra dot inverse. And this is your inverse. At the rate output. Right, that's it. Now you print here solution equal to /n and you say result. Now when you run it, so it
So may I
says,
just have,
yes,
sorry to break you. So
no
I
problem.
have one question, right? So
Uh-huh.
so if it is equal, right, or the determinant is zero, that means the formula or the equation what we wrote is it cannot be possible.
It
Is it
has
what you're
infinite,
saying?
um, uh,
Value.
yes, infinite solution.
Oh, infinite solution. So how is that practically possible, for example?
It is practically
Oh,
possible.
okay.
Okay, so
With our
so it's,
mathematical formula, we can solve that anyway, right? You give any value, we can solve it. But here you cannot solve it. Is
yeah,
it what
yeah.
you're saying?
Okay, so I'm just thinking of an example. Okay, so let's say you have this equation. Okay, 2x plus 3y equal to 10 and 4x plus 6y equal to 20. Right? Now, in
Hmm.
this case, if you see this, so yeah, if you calculate determinant, it will be 0. 6 into 2 is 12, minus 4 into 3 is 12. This will be 0.
Oh, yeah.
In this case,
Okay.
you have determinant 0. And now you see, infinite solution. This is an infinite solution. Okay, for example, if I
Mm-hmm.
put y value as 0,
Hmm.
the next value is 5.
7. Yeah.
5, right? 5 into
Seven.
2,
Oh, okay. Okay. Uh-huh.
right? So here, 0, this is 5 into 4. Now, x is 5. Now, if y is 1, then x is 2x equal to 7, 7 by 2,
7,
3.5.
7 by 2. Yeah.
See? When y is 2,
So it means you can have multiple values for the variable. Is it what you're saying?
yes. But in this case, you'll have
Yeah.
only one value.
Yeah, this is a unique. Okay. So
Unique.
if you want to find only one value
Yeah,
of
see,
X and
I see
Y,
here also I'm giving from 0 to 1, right? I could
yeah.
have said 0.001.
Mm-hmm.
Even then you'll have y. So infinite solution.
Okay, okay, okay. Yeah.
And you put any value for y, there will be corresponding x value for this.
So will the system generate around 10? I can, so why is not,
No,
it's not
infinite,
capable
no,
to
this is
generate
not
that
possible.
numbers?
Infinite, you can't even imagine. No, everything is a solution,
Wow. Okay, okay.
right? You just have to fix one, either x or y.
Yeah.
And you fix one, x or y you fix, you'll definitely have value for others. If it is
Mm-hmm.
one or two, it makes
Yeah.
sense.
Yeah.
But if it is many, then it makes sense, right? So it
Mm-hmm.
says that, okay, you do not have, you have infinite solution for this problem.
Wow. Okay.
But here, your x is 5.7 and y is 0.7.
These are the only value it
Only
can accept.
value.
Got it, got it. Yeah.
Now let's imagine in our head, let's do back calculation, okay? Let's say, okay, we'll put x equal to 3 and y equal to 7, let's say.
Mm.
If you say x equal to 3 and y equal to 7, back calculation, okay? So this
Mm-hmm.
will be 6 plus 35.
6 plus 35. Yeah, yeah. It's
So
not
6
equal.
plus 41, correct?
Mm.
And this is going to be 9 plus 28. 37. Correct? So now if we make 41, 37 here, 41, 37. See, 3 and 7.
It gives that value. Okay.
That's how we got 3
That's
and
the unique value. Okay.
yeah, unique value. So this is how you can use to solve this linear algebra problem.
That's good. And this is out of the context here.
Huh?
Is any of the institute have started using this to the education system?